Hello fellow mathematicians, and today we are going to solve a problem regarding the gamma function. So let us begin. So let us first look at the formula of the gamma function, where the t term, or same like a t term, or that is called the gamma. So gamma of n is equal to the integral from 0 to infinity e to the power minus x to the power n minus 1 dx, where n is greater than 0. So that is the condition which satisfies the gamma function. When n is less than 0, it never satisfies the function, and that function is never called a gamma function. And if n is greater than 0, then only it is called the gamma function. So now let's look at another formula that we might require to solve the problem that I'm going to give you right now. So the formula goes on this way. So it's in the trig form. So gamma of m times gamma of 1 minus m is equal to pi over sine of m pi, where m is between 0 and 1. And when m is between 0 and 1, only then this relation satisfies, where this equation can be related with. Now we have this, we have two formulas. Now we can easily solve the problem. So let us look at the question first. So the question goes on this way. So the question is integral from 0 to infinity e to the power minus x to the power 4x squared dx into integral from 0 to infinity e to the power minus x to the power 4 dx. Now what we do is we use the substitution method. So let us substitute t is equal to x to the power 4 and take its derivative. And after we do that, we get the following result. X to the power 4 is equal to t. We take its derivative, we'll get 4x to the power cube, and we just replace it or rearrange it, and we get the following result. Dx is equal to dt over 4x to the power cube. Now what we do is we will use another substitution that might relate x squared in terms of t. So the substitution is this, and we are not going to take the derivative of this because we are going to directly use the substitution, because everything is in t form, so we can have some relation after we have everything in t form, because as we already have x to the power 4 in terms of t, but we don't have x squared in terms of t, so we have to develop an idea to bring x to the power squared is equal to t to the power 1 by 2, as we can even say that when we simplify this, x squared is equal to t to the power 1 by 2, we'll get the same result as x to the power 4 is equal to t. So this is the problem that I'm going to leave to you to find it out yourself. Now what we are going to do is we are just going to substitute everything that you have got right now here. So what we are going to do is we are going to substitute everything, we'll get the following results. But you can even see that we have x to the power cube term. So what we are going to do for the x to the power cube term, we are going to do the same thing that we have done for the x squared term. So after we do the same thing which we have done with the x squared term, we get the following results. So we get x to the power cube is equal to t to the power 3 by 4. Now everything is in the t form. So we already have x squared in terms of t. We now have x to the power cube in terms of t. Now we can have some solution pretty easily. So now what do we have is this thing. So we have integral from 0 to infinity e to the power minus t to the power 1 by 2 dt over 4 times t to the power 3 by 4 into integral from 0 to infinity e to the power minus t dt over 4 t to the power 3 by 4. Now what we are going to use is we are going to use the law of indices. Now as you have already studied the laws of indices, the powers, if they are one power is in the denominator and one power is in the numerator, and with the same basis they subtract each other, their powers subtract each other. So we are going to use that rule and we are going to solve some questions right now. So what we are going to do is the main question is how can we get rid of the two bases of t in the green highlighted boxes, right? So the powers, so we can relate the powers, so we can use the rules of indices for this. So as we know that 4 is a constant, we can take 4 out of the integral form, right? And we can use the law of indices, and we can find that t to the power 1 by 2 times 1 over t to the power 3 by 4 is equal to t to the power minus 1 by 4. So this is it. So now substitute it in the equation, taking the constants out of the integral, and you'll get the following result. So after you take the constants out, you can just multiply those constants as I have already highlighted in the red boxes. So the boxes can be multiplied with each other and you'll get the following result, 1 over 16. So after you do that, what do you get is 1 over 16 integral from 0 to infinity e to the power minus t to the power 1 by 4 dt into integral from 0 to infinity e to the power minus t to the power minus 3 by 4 dt. Now, this is it. So after this, we cannot do anything. So what we are going to use is we are going to use the gamma function for this. As we already know that gamma of n is equal to integral from 0 to infinity e to the power minus x to the power n minus 1 dx, where n is always greater than 0. Now, if we relate that equation with the following terms that we have applied and got from the equation, we are going to say that t is equal to x, and we already know that they are equal because we have substituted x to the power 4 as t, right? So in the place of t we can replace x, or x and t are the same thing. It's not about replacing, but we are just recognizing that it deals with the formula. And the one thing we don't have is n minus 1 term. So how can we find n minus 1 term? It's easy enough because n minus 1 is equal to minus 1 by 4. So we can do it by that way. So if we say that n minus 1 is equal to minus 1 by 4, or n is equal to 3 by 4, in the same way we can do it for another term. So we are going to get 3 by 4 minus 1 and 1 by 4 minus 1 in the power term. Now we can easily form the gamma function. So the value might be 1 over 16 gamma of 3 by 4 times gamma of 1 by 4. So that's it, right? Now, after this, we are going to use the formula that we have already shown you in the first slide. So this formula is the most basic formula of gamma functions. This is the property of the gamma function when the gamma of m times the gamma of 1 minus m is equal to pi over sine m pi, where m is between 0 and 1. What you can do is you can just simply look at the pattern for which you can substitute it and for which you can rearrange it to get it into that form of gamma of m times gamma of 1 minus m. And after you do that, you just apply the formula and you'll get this thing. So after you do this, so as you already know that sine pi over 4 is 1 over root 2, that is equal to 1 over 16 root 2 pi. And yeah, this is the value of the integration. And yeah, thank you for watching.